Thank you very much, Ms. Hirose. I am Obayashi from the Renewable Energy Institute. We'd like to start the second session for today. The first session from Denmark, from Ørsted and Energinet, we invited two keynote speakers to talk about Denmark. From the 1970s, Denmark has been focusing on wind power development, and now wind power accounts for 50%. And so the two experts from Denmark talked about their history. In the second session, we have invited Mr. Yamazaki from the Agency of Natural Resources and Energy, Mr. Kutu, Mr. Yamada from MHI Vestas, and Mr. Sato from Toda Corporation, and Mr. Wakutu from Niigata Prefectural Government. We have invited these speakers from Japan in the second session, and they are different types of stakeholders. And in order to promote wind power development in Japan, what is necessary? That will be the topic of the second session, inviting Japanese speakers. Wind power. In the late 1990s, we started the commercial operation of wind power in Japan. We have less than 4 gigawatts, even for offshore and onshore wind power put together. And we are focusing on the offshore wind power in Japan. And we have a plan to develop more than 1 gigawatts of offshore wind power in Japan. Under such circumstances, Renewable Energy Institute is trying to come up with a new proposal for offshore wind power development. We need a new bill. What do you think about the prospects of a bill for offshore wind power development realizing in Japan? First, we would like to call upon Mr. Yamazaki from Agency for Natural Resources and Energy to deliver his presentation.
Thank you very much for the introduction, Ms. Obayashi. My name is Yamazaki from the Agency for Natural Resources and Energy. Thank you for giving me this opportunity to speak today. I assumed my present position 2 years ago as Director of Renewable Energy Division, and we decided at that time in our country to promote renewable, and we have been diverting the past 2 years our resources to renewables. So this is an area very dear to my heart. And so at the onset, I would like to, during the panel discussions, to talk about the current Japanese government position to renewables and its introduction into our country. So I'm preaching to the already learned here, but renewable energies is becoming mainstream, a lot of investments, but in either case, depending on the type, of course, but it has become a irreversible trend to have more renewables as a power generation source. The shift has now accelerated. So in the past 10 years or so, it shows wind and so we have seen drastic declines in the cost of wind power generation, and this has become a big driver. So centering our own solar and wind, variable renewables are becoming mainstream. And compared to other sources, it is no longer high cost anymore. The costs are coming down. So in any country, if you look at the history of introduction of renewables, they were high cost, but economics, energy security, and environment. So we often talked about it in the sense of the 3 E's, but in terms of economics, it has gone down. So there is renewables. The cost has come down. So in the beginning, all countries thought renewables were high cost, but it's coming down drastically. And the same can be said for Japan. And right now, we only use 14.5% renewables at present, but by 2030, we'd like to have 22 to 24% of our energy from renewables. And I'm often scolded for being this threshold, this goal being too low. I've been involved in renewables for the past 2 years, but because we use a lot of power in Japan, this 24% to be realized by 2030, there are a lot of things that we have to do before if we are to achieve this level. And yesterday, I was involved in a council meeting, and I received an interview from a TV broadcasting. And my interview, incidentally, was not broadcast, but I was asked whether achieving 24% renewables was an easy task. I said no. We had to implement a lot of measures if we want to achieve 24% renewables by 2030. I don't want to go into details, but be it solar, if we have not yet come to use all the capacity, and in the 440 that you see here, you see many small units. So in that sense, even if we achieve the threshold, we need further investments to make it sustainable. So these figures are very challenging. But of course, we do not want to remain at 24%. As long as the conditions can be overcome, we want to further enhance and expand the share of renewables. So we want to go beyond 24%. But right now, 24% is difficult to attain. But in order to implement this, we have to look further into offshore wind. Now, a lot of people don't want to listen to this story, but we got to the tariff, 2.4 trillion yen is given out as subsidies to the various entities involved. And we were talking about this in the council meeting yesterday as well. The FIT in 2012, FIT began in Japan, and renewables only had 10% right before that. And right now, it has come to 14.5 or almost 15%. So to go from 10 to 15%, as you can see here, so it took 2 trillion yen. And in Germany, how much did it take? How much did it cost for the UK when we did a calculation? And the German power tariff, they use less. So it's not fair to compare in total terms, but per hour, if we look at the situation of 2.25 yen, but in Germany, it's 0.6 yen per kilowatt hour, and it's at 5%. And for the UK, it was 0.2, 0.3 yen. So in that sense, unfortunately, in order to increase the percentage, we had to ask the people to shoulder a big cost burden. Especially we, the policymakers, have to look at this reality to maximize the use of the renewables. And but we have to keep down the cost burden for our people. So for offshore wind as well, with this in the backdrop, we are discussing how this can be advanced further. Now in May, ultimately in July, actually, but we had a cabinet decision on the fifth energy basic plan. And for the first time, renewables has been positioned as a mainstream of power. And of course, this is already a global trend, and we are going to incorporate this in Japan. Maybe not so right now, but this is unavoidable as we head toward 2030, 2050. Renewables is going to be mainstream, and so this is how we are positioning renewables going forward, and we will continue and undeniably pursue policies in that direction. And what measures can we take to make sure that renewables become a main source of power. And we will upload this so you can see this on the web to look into the details. But for renewables, in order to make it mainstream, there are two conditions. And as institutions, we need infrastructure. So what are the two conditions? First, well, unfortunately, in Japan, renewable costs are still high. So how can we bring them low compared to other power sources? So we have to pursue costs that are in line with global standards. And the other condition, as you can see here, long-term stable supply of electricity. So it's not just investment sake per se, but we have to look at stable supply of energy in the long run. So there is responsibility and a goal for society. So those are the conditions that we need to make renewables a main source of power. But there are challenges. And when we overcome these challenges, renewables as a main power source will become more developed. So we do feel that renewables have a lot of potential. But in order to advance, and I'm sure many of you represent the operators, but of course there's the grid issue. And so unfortunately in Japan, after the war, the electricity system, Okinawa is not connected yet, so I'm going to put that aside for the main thing. But we have 9 utilities, and each have their responsibility, their areas. In the past 6 years, supply and demand balance was kept within these 9 geographic regions, and this has, for the better or worse, has supported Japan's economic growth, especially for offshore wind. The transmission system, as it is today, is very weak, and so there are limitations and regulations on transmission and the grid. And so we have to do all we can at the Ministry of Economy, Trade and Industry to improve the situation. So we think about reforming the electricity market. We have to set up cross-regional coordination operators, and we will be unbundling. Of course, we don't know how many years we are behind compared to Europe in terms of unbundling generation from transmission, but finally we are coming close to that. So we are doing a review of the whole power system, and in addition to that, the Japanese version, Connect and Manage, we are implementing to use whatever available transmission capacity, but there are limits to how much we can do this. So as you can see here, we have to enhance the transmission system, and when we do that, so we can't be random. We have to look at the whole of the system where we can minimize the cost and where it's legally permissible. In Hokkaido, there was an earthquake, so we have, and this has led us to talk about resilience and the use of renewables. So there have been issues that have surfaced, so we'd like to look forward. And we got to regulation and adjustment. So as an adjustment factor, like you see in Spain, there are various mechanisms to adjust, and this is complemented by thermal power plants as well as the use of batteries. So if the two conditions are met, and if the infrastructure can enable flexibility in adjustment, then we can employ more renewables as a power source. So in the Energy Basic Plan, the content here, in order to make this more concrete, in August 29th, we began review in this council meeting. In phase 1, we made the announcement that renewables will be the mainstream. Connect and Manage has been set out as a policy, and in order to accelerate this, how can we bring down cost faster and long-term stable supply of power? How can we realize this? And we have developed a action plan. And as player, how are we going to enhance industrial competitiveness? So we have begun a study from August 29th, and for offshore wind as well, we are discussing the possibilities. So I'm going to skip this page. With regard to industrial competitiveness, I'd like to explain a bit now. As you well know, in Europe, there are big utilities that have accelerated investments into renewables. And if you will look at this example, these are the main utility companies in Europe. EDF, you have the image that they are involved in nuclear, but 6% is renewable. And Yvette Laura, so they're 30%, so the biggest wind generation. So in comparison, what is the situation in Japan is very small, but we have made a list of the top 10 in Japan as generators. So it's negligible. So even with the biggest Kyushu, this is geothermal, 1.11%. So as you can see here, there are various players in the renewable market, but there are no mega players that have entered the renewables market in Japan yet. So these players, we hope that they will look forward, and we don't want them to be utilities that are resistant to the introduction of renewables. We hope that they will look forward, and I think improvement has been made. They are looking seriously into renewables. Now, I don't have much time left, so now I'd like to get into offshore wind, and I'm sure that Yamada-san will be talking about this later. But in Europe, if we look at the trend for offshore wind, I'm not going to go into detail myself, but in Europe, the demonstrative, we have divided into phases of development, demonstration, testing and expansion, and then being competitive. So it's less than 10 yen on an auction basis, and zero subsidies. We are seeing many very competitive projects, a lot of success in offshore wind in Europe, and the market in Japan is still to be developed. So how can we jump in to offshore wind? How can we catch up as soon as possible to our European counterparts? We want to jump in this area to become expansive and competitive. So we are still in the demonstration stage, but we want to be bold and courageous and jump into later stages directly. And so this is the bill that we have been studying. Obayashi-san mentioned earlier in the maritime Oceanic study group under METI, and also the Ministry of Land Transport and Infrastructure we are all taking a cross-ministerial approach to look into offshore wind, but because of the parliament in Japan in the current sessions, they could not take it up, and so it is in the special sessions. We want to have our bill and have this deliberated in the Japanese parliament as soon as possible. And the background to this is that here, as you can see, as I mentioned before, from expansion to going into the competitive phase, we want to jump right into as soon as possible to the competitive phase, looking at the European example. The central approach, we have not seeing the central approach yet, but we want to take in the central approach, and we want to see expansion in offshore wind. But there are 5 challenges. First, there are no rules to the use of territorial sea, and so once you are permitted under the law, you can use the sea for 30 years maximum, and the same can be said for other countries, but in Japan there are a lot of people using the sea, so fisheries, shipping. So there is no mechanism yet to adjust to other users of the sea, including the fishermen and the shipping companies. So we want to set up a consultative body through which how can we adjust the interest with whom with regard to the use of the seas. So for the territorial waters, who has the rights? And we need a mechanism to coordinate. So based on these two pillars, as you all know, FIT is 36 yen, and how can we keep down the burden on the people? So 36 yen cannot be maintained as a FIT price. So renewables cannot be accepted if FIT is kept at 36. So that is the reality. So how are we going to bring this down? We have to take a concerted approach, or if we don't, offshore wind cannot brought in. So we will be price competitive by bringing in an auction system, and this decrease the pricing. And the government will decide the area of the seas, and people who have rights. It will be based on a public offering, and there will be a auction. So in the present as well as the next Parliament session, we will deliberate and have it passed as a law. And we need a grid, or else there is no meaning in generation. So we have to connect and manage, and we need to manage the connectors, and we need to make sure all these systems are in place. And we have to do an environmental assessment of the seas as soon as possible, and how much in the water we have. How much measures we have to take in order to prevent contamination or destruction of oceanic life and environment in the sea. And so to make renewables a mainstream in a power source, we have now made it mainstream, but we have to make sure that it can be stably supplied on the long run, and it is price competitive. So if we make progress in this area, renewables can become mainstream as a power source. And we hope that big players will be participating in the market. So it is high time for game changers to come into the market. And we feel that offshore wind is indispensable in the total formula. So we need to come up with proper rules for the use of territorial seas and the use of the transmission. And therefore, the pricing right now is 36 yen. It's too high. So we have to be able to generate and use renewables without depending on FIT. And we have to coexist with the local regions. And the government has to come up with adjustment and coordinating mechanisms, or else we will not be able to supply for longer terms stably. So there are challenges, and some parts of the road may be bumpy, but the government would like to strongly push ahead so that renewables can truly become a main source of power. Thank you very much. So we are running out of time. So later on, we will be entertaining questions from the floor. But if I may, just one question from me. But the auction on offshore wind, you said that we will take the central approach, and the government will decide which sea area. But with regard to transmission and grid, who is going to decide what is going to be the mechanisms involved? Well, at present, in the present law that we are studying, with regard to the grid, the situation for the transmission, when we designate the area, we will, in the draft of the law, look into the potential transmission lines. We will prepare transmission lines. I'm sorry, it's going to take a long time to explain, but there are various aspects involved overseas as well. I'm sure it's the same, but are we going to connect with having curtailment in mind, collect and manage if this is to be implemented in Japan, the same, but if we are going to assume curtailment, if it's going to be 14%, and if we have to do it at 15 yen, the operator is going to say we can't afford to do that. So we have to think of the balance, and so we have to come up with challenges with regard to transmission and grid, and so the government has to come up with a framework to enable this advancement. So maybe later on we can have deeper discussion on this. From Denmark, offshore wind, as a manufacturer of the wind facilities, we'd like to ask Mr. Yamada from MHI Vesta.
Mr. Yamada is Chief Strategy Officer at MHI Vestas Offshore Wind. The floor is yours, Mr. Yamada. Ms. Obayashi, thank you for the introduction. As has been introduced, I'm Chief Strategy Officer responsible for business strategy at MHI Vestas Offshore Wind. In April 2014, I founded this company. I was dispatched to this company and I was stationed in Denmark. It's been 5 years since. In the last 5 years, I have been on the forefront of European energy industry and looking at Japan's energy market as an outsider. And I realized that there's a growing gap between what's going on in Japan and what's happening in Europe. We have experts from Denmark today. I'm looking forward to engaging in constructive discussions with them later. First of all, about our company. It's a joint venture between MHI and Denmark's Vestas. It is an offshore wind specialist. It is situated in Aarhus, the second largest city in Denmark. And in April, we welcomed a new president, Philip Kavafian, and co-CEO, Danish, Lars Bondo Krogsgaard. We have over 2,600 employees. Of that number, 21 Japanese expats are dispatched from MHI. So they're working very well and actively with their Danish colleagues. Now, we have two main business lines. Second from the right, V112, 117, 4 mega platform for both onshore and offshore, and V164, 8 or 9.5, 10 megawatt. And this is the largest wind turbines of this kind in the world. And I would like to show you, to put this in perspective, how large they are. V164, this shows the rotor diameter. And you can see that a 380 Airbus aircraft for them can be included 80-meter length of a blade. That's 3 Shinkansen bullet trains, 187 meters, approximately tip height. 174 meters, that is the highest mountain in Denmark, so 3 more meters higher than that. And as Yamazaki-san said, there's a need to bring the cost down. How can we bring the cost down for offshore wind? As a manufacturer, what do we have in mind? Offshore wind conditions are better than onshore, less land or spatial constraint, so large plants are possible, but from construction to operation, you have to do everything offshore. So operational difficulties and risks are always involved. So as a manufacturer, we would like to develop a reliable wind turbine blade. And because construction is demanding, we need to shorten the construction period to the extent possible, keep it to a minimum. And once a wind plant is up and running, we should make sure that it keeps on running. Now, in order to develop reliable wind turbines, what is most important from our perspective is demonstration work. And the most difficult part of our work is in the 20 years or 25 years of its operation, what kind of damage could happen to wind turbines, what problems could occur. You cannot capture every possible scenario and calculate them. So what a Texan company has in the facility there, all the components are tested, assemblies are tested under actual conditions. So we run these durability tests until they break down. V80, V90. We used to have those old turbines. Compared to this failure rate, initial failure rate is kept to 50% of what it used to be. It's not just the size that's been improving. Turbines do not run on a standalone basis. They can be now controlled for the whole of the plant. We call max cap. We use that software. And one turbine for inspection and trouble when it stops. The other turbines will increase its output so that for the whole of the plant, the overall output can be maintained and kept at a certain level. Now, in order to shorten the construction period, what is crucial is to do whatever you can onshore to the maximum. For example, the power installation and interior or assembly testing, pilot running. Before they're put onshore, they should be done onshore or on the vessel. And you set up the tower, and then you bring the turbine to install it. So with these approaches, construction period can be reduced and weather risks mitigated. With this, the latest 8-megawatt wind power plant is shown in this video. So if you could please take a look at this video. Riverbank extension video that we supplied to Orsted, and this is about maintenance. In order to maintain high operation efficiency, what is most important is human resources. I say so because maintaining a wind power plant offshore requires a lot of manpower, physical, mental, technical burden is much, much greater than on shore. So technicians are given very thorough simulation exercises. They're taught the required technical knowledge so that when they're sent out onshore, they won't face any risks. So we have this real-size 3D simulator, and we use the simulator to give training, thorough training to our engineers. I have a video for that, so please watch.
Offshore wind, innovation is at the heart of everything we do. To ensure our workforce has the right skill set to keep the world's most powerful wind turbine running effectively, we are investing in future-proof ways of training our team of experienced service technicians. Through challenging our existing methods, we developed a digital simulator, a replica virtually identical to the V164 8-megawatt turbine. Our solution is a sustainable and portable training program that offers real-time software updates plugged into a mobile 3D setup. At approximately a third of the cost of a traditional simulator, our solution is extremely cost-effective and reinforces the MHI Vestas commitment to reducing the cost of energy. In training, mobility and flexibility rule. Now we can facilitate training where it is needed and ensure that our technicians are always fully prepared before sailing out.
Well, to continue, so how the system in offshore wind system has changed in Europe and what we can learn from Europe. So offshore wind was limited to Europe, but recently we're seeing cases in Taiwan, the US, and Japan. We're seeing an increasing number of such projects. It will continue to grow, and the rate is expected to be 20% growth year on year going forward. And in the last few years, Well, prices have come down dramatically in auctions organized in Europe, starting in UK, Denmark, Holland, Denmark and Holland. As you can see, exponentially it's coming down. Auction prices are down dramatically. In Germany last year, this year in Holland, the auction price achieved was 0 in some of the projects. And 6 yen per kilowatt hour. So amazing price has been achieved. Why can this happen? How is this possible? We looked into the factors. First of all, governments are very active in setting up long-term goals that are massive. And operators are now able to take advantage of scale of economy. They can get the money back. And through innovation, turbines are becoming larger, and construction cost is coming down. And lastly, market and industry have become mature. Risks are brought down. Cost is down as well. Capital cost, in other words, is down. So with these three conditions in place, the government organized these auctions, and therefore competition was enhanced to its peak. And auction prices are down. That means that the taxpayers' burden is down for the general public. Well, then that will encourage the government to introduce similar projects even more, and that will lead to greater scale of economy. So it's based on market principles, creating favorable cycle in Europe. Now, let us expand our perspective and intellectual horizon, and we would like to think about the implications for Japan. And let me share my thinking with you. There's this terminology, energy geopolitics, and renewable energy may change this. People say 20th century was the era of oil. So those who have oil and those other countries who did not have oil, there was always conflict. And that was the driver for politics, economy, diplomacy, and military. It even caused wars. But in the 21st century, where the share of RE is increasing, these conditions may change. In other words, RE to some extent, is available to every country. The question is whether you can utilize it, or you need technological innovation, you need to develop shale, you need policies and funding. And if the country is active on that, the country will be able to utilize and negotiate well in terms of RE vis-a-vis other countries. It's not just Europe, but various countries around the world are now focusing on RE. It's not just for global warming. It is part of the larger, broader national strategy. The greatest factor, as was mentioned, is that RE cost has become cheaper than fossil fuel. And yet, FIT price in Japan is hovering very high. So there's this large gap. And there's also a gap on the part of the Japanese public when it comes to awareness. Orsted last year conducted a survey among 2,000 consumers in 13 countries, and these are the results of the survey they did. So do you believe in the possibility of RE? Among the 13 countries covered, Japan came out lowest. Smallest number of people who believe in the possibility of RE. That's unfortunate. And this is in line with what Mr. Yamazaki said. In order to increase RE, what should be done? Well, first and foremost, we need a strong commitment on the part of the government, the political world, and the general public to massively introduce renewable energy. And secondly, the government needs to develop the right systems and frameworks for that, as has been discussed. And thirdly, most importantly, we, the players in the private sector, need to bring in expertise, compete with each other, collaborate with each other, so that we can develop the cheapest, most efficient, most effective offshore wind. Unless these three conditions are met, we cannot promote offshore wind and bring the cost down. And RE as well. And RE, renewable energy, VRE, is relevant to SDGs of the 17 goals. VRE is relevant to almost all of them. It's very effective, very efficient in meeting SDGs. So let us all work together, join hands, join forces to push for the massive introduction of VRE. Thank you for your attention.
山田さん、ありがとうございます。
Thank you, Mr. Yamada. Next.
From the Industry Promotion Division of the Department of Industry, Labor and Tourism from Niigata Prefecture Government, Mr. Wakutsu, so along with Akita, Niigata is looking into wind and other power generation. So, Mr. Wakutsu, over to you. Thank you. My name is Wakutsu from Niigata Prefectural Government, the Industry Promotion Division. I'd like to thank you for giving me this opportunity to speak with the governor. We visited Denmark. We'd like to thank the people of the embassy very much for making the arrangements and your hospitality. Now, I'd like to introduce our prefecture, Niigata, to you. So people in Japan know about our prefecture, but I would like to give an overview. So upper, lower Japan, you see the whole of Japan, and if you will look at Niigata above Tokyo, we have a lot of area. As you can see, we are fifth largest prefecture in terms of area, and we are surrounded by seas and mountains. We have diversity in terms of terrain, and we have Sado, a big island. It is the second largest after Okinawa. And upper right, there is Awashima, another island, a remote island with less than 100 inhabitants, and snows in Niigata are quite famous, but Niigata and other cities near the coast, they don't have that much rain and snow. It doesn't mount as much, and from the north to the southern tip, the coast is about 330 kilometers, so we have a long coastline. So from Niigata to Tokyo, it's about 330, and so from Niigata to Okazaki, it's about 330, so roughly the same as the long coastline that we have. Now going on to discussion of renewables. So you have been discussing mainly wind, but I'd like to talk about hydro first, because as I mentioned, that Niigata is blessed with nature, and we have mountains areas. So first on hydro. So using nature, we have generated power from hydro, and so Shinano River, which is the longest river in Japan, and there are a lot of hydro plants alongside the river. One specific feature is, we belong in the district of Tohoku Electric Power Company, but we have JR Power, East Japan Railway Company, and TEPCO, so they have their facilities here. For JR East, Niigata people tend to be proud of the fact that the power generated in Niigata drives the Yamanote line in the center of Tokyo. And also, we are blessed with natural resources as well, so it's a different perspective than renewables. But just a recap of in Niigata, we are, for the most part, dependent on fossil fuel imports, but Niigata has its own small share of oil and natural gas. So Niigata has 80% of natural gas for the total of Japan and 69% for crude oil. So Niigata is a prefecture that has supported economic development in Japan. And if you look at upper right, we have gas fields in in the coastal areas. And the reason why I talk about fossil fuels, if you look at the next page, we have a lot of infrastructure. That is the point I wanted to mention. So for energy, because we have a lot of gas that we can harvest, we have a lot of gas pipelines, and we have a lot of LNG receiving terminals, and we have Niigata port, and now it's ports that we have terminals there to accept LNG. So the fact that we have receiving terminals, it means that we have a lot of thermal plants, and so we have 500 mega thermal power plant, and from this power plant to Tohoku Power Company, we provide power which is dispatched throughout the Tohoku area. So we have already a well-developed transmission grid system. Of course, they are used for thermal power generated electricity, but these transmission lines can be used because the government has said that they want to use existing transmissions when available. So bit by bit, we feel that the existing transmission lines can be made available for renewables, and also TEPCO's nuclear power plant we have in Kawarazaki. So we have transmission to send to Tokyo. So we do have a robust infrastructure already existing in our prefecture. Now, for this slide, you can see that for both hydro and thermal power plants, we have quite a bit. And so with regard to power generation within our prefecture, if you look at lower right, the amount of energy generated, well, in terms of we only use 2% of the total energy consumed, so GDP is about 1% of the total of the country, but we generate 5% of the power generated in Japan, and most of the power that we generate is exported outside our prefecture, and we are involved in a lot of hydropower generation, and so we have higher share of hydro and LNG fired power thermal plants. We have quite a bit. So we export power outside our prefecture. So in that sense, as Niigata Prefecture, it's not to say we are short of electricity, but we are transferring power outside. It's already clean in terms of resources, so we can generate clean power. And we have this much power generation capacity, even with nuclear power plants being closed. And so we do not have that much renewable power generation yet. So we would like to focus in that area. So the topic of this meeting is renewables as well as the next generation of energy to be used. We are involved in this area as well. But first of all, PV, I will not go into the details. However, for FIT, even before it was institutionalized by the central government, we have been involved in. So we have developed mega solar facilities directly managed by the prefecture, but there is a lot of snow in a prefecture, making it a little costly. And so it's not to say that PV has spread that much, but among the various prefectures in Japan, Niigata has been one of the pioneers and forerunners. Now, looking at other energy sources for Niigata, what is particular is that for heat, so we have a data center on the use of snow for use in cooling, so as a source of cool temperature, lower temperature. And now, if we look at wind power generation in Niigata, the volume is still low, but you see the locations and the output right now. We don't have offshore right now. It's all onshore. So along the coast, you see a lot of our wind facilities. So number two, within the city of Tainai, so a little north in our prefecture, we have Tainai Wind Farm. So you see the facilities there, but this is not enough. So we have a long coastline, and we have a lot of seas adjacent to our prefecture. So we would like to become involved full-fledged in offshore wind. And so within our prefecture, we did an independent survey on the potential 2 years ago, and as a result, you see here, first we got to the bottom mounted in orange. So along our coast line, we can bottom mount the offshore wind turbines, and for the floating type, because there are some areas where the seas become deeper, so we can use the floating type. So near Sado and Awashima, the remote islands, so in the seas in between, shown in green here, floating type wind turbines can be installed. And for the bottom mounted, among the coast in the northern areas, we have stronger winds. So to Yamagata and Akita, the coastline links itself, but there's a lot of high hopes of using these here. But there, the transmission lines are a little weak in terms of infrastructure. And for floating type, we see the seas around Sado being very favorable, but Sado is not connected to the main land by transmission side. So if we develop wind power generation near Sado, it will be more than enough for Sado. So we need to develop transmission to link the Sado grid to the rest of Japan. And so for adjustment with the island of Sado, another issue is the Japanese ibis. The birds are there, so some environmentalists may be concerned about birds, the ibis. But Awashima and Tainai, Murakami, these areas are viable because the gas and crude oil, they have experience in dealing with fossil fuels already, and so there are gas fields offshore. So the people are already used to energy and having pipelines, and so that's an asset for our prefecture. And if you look at the potential map here, so we have displayed this on our web page. So if you will refer to this map, if you are interested. Now, the initiatives that, as a prefecture, that we are involved in, the Awashima, so there are only 400 residents in this remote island, but we have made a demonstration field, and it's not just offshore wind, but we are using this as a central government designated ocean territory. And so we are adjusting with the local fisheries association. And so I think compared to other areas, we can readily coordinate. And Awashima only has 400 residents, so much smaller compared to Sado. If power is generated there, it would be much more than can be locally consumed. So we need transmission lines to connect. And within the prefecture, another initiative that we have, this is bottom Mount. In the north, Murakami City, offshore Iwafune, and from 2014 or so, in the locality here, they have begun to study offshore wind, and Murakami City has taken the lead, and they are planning, asking for players that may be interested. And so geological issues, because the ground is so hard that it's very difficult to drill to mount the bottom. So at present, the cost seems to be a little high because the sea bottom is too hard to drill efficiently. But this is a territorial sea that has a lot of potential, not just off Iwahune, but if you expand the area of the sea to go a little southward, I think the cost for transmission and the grid will be much lower as well. So even when we were planning for a larger number, when we discussed with Tohoku Electric Power Company, they were thinking of in the order of 10 billion yen or so. But even if we decrease the number of wind turbines, it would still cost 9 billion. And so actually, the greater the number, there would be bigger cost benefits. Here, this is the prefectural initiatives for this year. So we will conduct study groups and we will conduct meetings so that we can get the understanding of the local residents. And with new laws coming in to be passed by the Japanese parliament, we think the environment will change. And we hope that the power generated within the prefecture can be transferred to other prefectures. And the summary, as I mentioned at the onset, we are blessed as a prefecture from nature. It's a big prefecture, and in relation to offshore wind power generation, we have a long coastline, so that is an asset. Second point, we have the experience of being active in various other areas, including handling of gas, crude oil, with a lot of terminals where we accept LNG as well. And so the local residents are used to and understand energy. And thirdly, this is infrastructure, so be it the transmission lines, but I think we have some existing infrastructure that we can use, and the ports as well. Naoetsu and Niigata ports, we have big ports, and that will be important in constructing overseas in offshore wind. And if we look back in history, the ports that we have in our prefecture was one of the first ports to be opened. So using this infrastructure, we would like to advance in the introduction of renewables to our prefecture, Niigata. And we'd like to ask for your support. And if you're interested, please come and visit our prefecture. In the summer, it's moderate. The climate is good. And so even if you come to Niigata City, a lot of times it's cloudy, but with a lot of wind, so potential for wind power generation. And that is all. Thank you very much.
Called upon Japanese stakeholders to give their presentations, a person from the central government and also a person from a global company manufacturing wind turbines globally from MHI Vestas, Mr. Yamada, and then a regional Japanese wind turbine project was introduced by Mr. Sato of Tora Corporation, and Mr. Wakutu from the local government from Niigata Prefecture. Peta and Matthias, in that order, what is your impression of the presentation by the Japanese people, or any questions? Do you have any questions to the Japanese speakers?
Well, I think I have a clearer picture now of the opportunities and also the challenges in the Japanese system. First of all, I will say my impression is that you have all the wind resources available around Japan. You have a large amount of sites, possible sites, and wind resources available. And the technology is available. That's the first thing. The next one is that you need the long-term goals to be set by the government. And this is very important to attract the investors, to create the necessary framework for the big developers to get in, and they have to see some large-scale project to benefit from scale of economy and build up the whole value chain for building and construction. And this calls for a need for a strong commitment from the government. That was the first two issues. Then the third one is the whole regulatory framework to be put in place, to give the right incentives for the big companies, the transmission grid operator, and all the utilities to support this development. And this is a matter of money and incentives for doing the right thing. And I was very happy to hear Mr. Yamazaki mention the option for a regional system operator. And that's the first step. I would say for one country, you should have one transmission system operator in Japan, or at least some regional transmission system operators that have to work together, plan together, as we do it in Europe, to bring the infrastructure in place. And then the competitive market to get the right prices, because I was very surprised to hear the very high level of levelized cost of renewable energy in Japan. And I don't see any reason why it should be higher in Japan than in any other places in the world, because you have the resources, the technology available is exactly the same. So it's a matter of regulatory framework. Thank you.
ありがとうございます。
I'm fine, thank you. Obviously, I cannot comment on all presentations. Sorry, I had to step out for, I did not hear all of them. What I took away is that there was an encouragement for new players or foreign players to also contribute to helping or supporting the market to achieve like certain build-out rates, but also cost reductions. In that sense, I would like to repeat what I said earlier in the morning. I think one thing is to create a successful market by making it a sustainable market, where we have players in there with a long-term agenda, with commitment, and also a significant amount of local but also experienced foreign players partnering up or working together on a supplier-customer basis or on an equal level. There's many different ways of collaboration, also on the financing side. Secondly, I think the market is only successful if it's long-term, of course, and there's a certain volume and the targets are there and also achievable targets. Secondly, it's also only successful if you bring the cost down, like Peter just said, make it competitive. What I have shown in the presentation is that we clearly see a higher capex and higher LCOE for offshore wind in Japan, but I can also very much see the cost reduction potential after a certain period of support. But I think we are very well prepared for playing a role here and helping with our experience to repeat the same success story on cost reduction as we have seen it in Europe or lately in Taiwan. Thank you.
ありがとうございます。それではちょっと今お話しいただいたことも含めて私。
Thank you very much. So I'd like to ask Mr. Yamazaki and then Yamada. My first question, as Peter-san emphasized, long-term goals must be set. I think this is very true. And by 2030, 22 to 24% is not low for the share of renewables. So 2030, in that case, if that is the goal, so the remaining 76% will come from other energy sources. And if we think of non-fossil fuels, 56% must come from other sources. And if that is the situation, then 2050, more longer-term goals, IPCC right now 2 weeks ago in Korea. They summarized a report. So even at 1.5, there's big impact on the environment. So we are involved with renewables and climate change. And I like renewables. And I am surprised at the gap in the perception that we have in Japan. We have a gap between the policies on renewables and climate change policies. So we have set a goal of 80% reduction in emissions, but 56% of non-renewables, that's quite low as a goal. Germany has set 65% renewables by 2030, and I think for Japan, the renewables goal is much less ambitious. Next, for Mr. Yamada, there are cost challenges, as mentioned by Mr. Sato, but Ørsted and other data from Denmark has shown that cost is coming down, and therefore MHI Vesta, so you are involved in that. You have not been involved in full-fledged matter on a commercial basis in Japan, but the possibility of cost reduction within Japan, and Matthias-san also mentioned the possibility, but how do you view cost reduction potential in Japan? So those two areas, please. Thank you very much for your question. And Ms. Obayashi scolds me all the time. She's always angry with me, but it's the first time that she pointedly, directly tells me all these very difficult things. And I want to avoid misunderstanding. I myself, the Japanese government, we're not saying that 24% of renewable share is the ultimate goal. We don't we don't intend to stop there. But I mentioned 24% share of renewables in terms of the speed, thinking of the existing power systems. There are challenges to be overcome. And if, for example, about PV, solar, and so the energy mix, we have set out as a goal of 64 million kilowatts, and so 40% would come from very small units of 50 kilowatts, and so even if we achieve a certain level, they tend to come down a little later on for solar, and we often discuss this with Obayashi-san, and she gets mad at me, but we have to think of the regional potential. We don't have a lot of flat land in Japan, so if we invest a lot and incur a lot of cost, some of the locations are viable. But if we try to efficiently use the money that we have, there are limits to what we can do, the installations for renewables. So 24% of renewables is quite an ambitious high target for the government. And so we need to implement various measures, both public and private. And so we don't intend to say 24% is the goal. We want to further expand this share. But for renewables, including offshore wind, we want them to expand and take root, and we need to transform the electricity and power system in Japan. And unfortunately, after the war, Japan was divided into 9 areas, but in 2020, as we had and changed the legal framework, and we are heading for unbundling of transmission and generation, it will trigger a change. So April 2020, to prepare for unbundling, we are preparing a lot of measures. So we have not yet determined how the TSO relationship is going to take root. But how can we use transmissions lines which do not presently exist, but if they can be built on a low-cost basis, we can transmit electricity from the northern tip of Japan to Tokyo or whatever. And so even if we make a large investment, if we think of the social and economic welfare of the people, this is viable. So with these considerations in mind, once we reach 24%, we can make further leaps and bounds forward and jump ahead. But right now, compared to Europe, the cost of renewables in Japan are roughly double, especially if we look at solar. So we have to bring down the cost as soon as possible, and when we are able to do that, we can expand renewable installation. In regard to offshore wind, we have not set a specific target for offshore wind generation yet. By 2030 for wind, in the energy mix, 10 giga is what we have set as an objective. But energy mix 10 giga for wind by 2030, I think is too low. So we have to expand this volume. And what is the government has to set long-term goals and say them. I do understand that just me talking about it is not enough, but the Japanese government is quite serious in that as we head in this direction, then even if we do not have specifics, are we going to go to 20 mega or 30 20 million or 30 million? We have already shown strong determination of the government to go in the direction of renewables, and that isn't changed.
Now, before addressing a question directed to me, let me comment on Mr. Yamazaki. 10 gigabit is nearly not enough. I completely agree. 12 gigawatt is being constructed in Taiwan, our neighbor, and given the size of our country, 10 gigawatt, including both onshore and offshore, that's not a lot. That's not nearly enough. Now, to address a question to me, in order to bring down the cost of offshore wind, what can be done? In my slides that I presented earlier, I showed you the drivers of cost reduction in Europe. They may have been rather abstract, but scale of economy, because wind power was introduced massively, cost came down and payback increased. For example, the cost of specialized vessels for construction, port development, or facilities, including towers, capex is required for that. And these all add up to cost. And so if you have massive volume, then the cost comes down. Unless you know that there is a critical volume that you can go after, companies do not invest. And of course, it's not something that you promise to the government or the government promises to someone. 10 gigawatt, 12 gigawatt, if you see a business chance, you make an investment of your own. But then when it's unclear, capex is not increased, and cost does not come down. That is the present state. With respect to technological advances, the same with our turbines, the ships, vessels in Europe. There is latest state-of-the-art technology available. So it's about bringing that state-of-the-art technology from Europe to Japan. That is very much possible. That can be done. Matiya-san is doing exactly that in Taiwan, our neighbor. Last but not least, the learning curve. That may be difficult to understand. Project management, process management, planning, and how to determine the scope of the project amongst the players, subcontractors. Such practical work becomes crucial in making the project a success. Unless you're matured and you have experience in that, the costs could rise. Europe has spent 20 years building expertise in that. And so here in Japan, we should not reinvent the wheel, because we won't be able to catch up with Europe if we spend as many years as Europe did. So if there's experience already accumulated in Europe, why not tie up with Europe, or why not compete with European players? Well, that may be scary for Japanese players, but there's a chance in partnering with European players so that know-how can be transferred from Europe to Japan. Given the technological prowess of this country, I don't think there is going to be a problem. We should not be fearful. Well, Mr. Yamazaki showed a graph. This is where we need to be, he said. I can't agree more. So those are the drivers. And if those drivers are in place, and if there's a competitive auction, and if you can see with transparency the volume in the future, you can invest. And if the volume is there to profit from, then the cost can be made efficient. Well, otherwise, businesses will not make investment. That is how businesses operate. So I do hope that clear targets will be set. Well, sorry, just to clarify. Well, there are. Well, Mr. Sato talked about the continental shelf being pretty steep in Japan. So technological differences that would increase the cost. Of course, fixed type and floating type. Of course, floating is challenging, and we have to be at the forefront of developing such technology. But the fixed type, well, the wave being high or lightning and typhoons hitting the side, there are such difficulties. But they can be overcome, as Matthias-san said. Of course, with a slightly increased capex and volume, you are able to recoup the cost. It's not a technological barrier that you cannot overcome. Thank you. Thank you very much for the clear answer.
Now, next, I'd like to ask Mr. Wakutsu from Niigata Prefecture. Actually, 2 months ago, I went to the city of Murakami, and I gave a lecture there. And as Wakutsu-san, you mentioned to connect to the grid, then 10 billion would be required. Then if you lower the capacity, then it would be 10 billion, so not much lower than the total 10 billion. So for one project, if it's difficult for entities within one group to share the cost, but as a policy issue, what can we do to bring down the connection to the grid? So what is your idea on lowering transmission cost? And Peter, as well, in Denmark, how do you share the transmission cost and the investments for transmission? So first, Mr. Wakutsu. Thank you very much for wind power off Iwafune. So we asked Ms. Obayashi to come and give a lecture to study the potential there. And initially, at large scale, we were told that it would be very costly. And so that is why we try to diminish the output and the capability. On a monopile, it was difficult to drill, and so we had to reduce the scale. And then we asked again how much it would cost, but the cost was almost the same. And I don't know about the technology, but the cost is almost the same, even if the scale is lower. And so as you build a transmission, the scale is really not that relevant to the cost because of how it's built. But if we can collect a lot of wind-powered projects, then the cost could be lowered. And I think for Akita as well, the central government is looking into potential. And if we can collect a lot of initiatives in our prefecture, Niigata, it will get better. And therefore, I think people want to build these wind turbines when the wind is strong. But we may be, instead of picking an area based on the strength of the wind, maybe if we pick a location close to an existing transmission line, it would be better and the cost can be brought down. So the companies have to think of constructing wind facilities where it is viable, and locations where transmission lines could be readily built or near transmission lines. And the assets that are existing in terms of transmission lines. But when we enter a unbundling era, the revenue from transmission lines, isn't there an investment scheme? Mr. Yamazaki, if you could comment.
Yes, thank you for the question. I would like to say two things. Number one, to address Ms. Obayashi's question, I think it's going to be difficult. So specified burden or general burden. Japan's system is for specified burden. In other words, generators and electric power companies, they will have to bear more of the cost for transmission. General burden is to try to recoup the cost through wheeling, a more general, a broader distribution. And so cost is overly imposed upon the generator under the Japanese system. So specified burden versus general burden. We need to review the relationship between the two. We came up with a policy in April, and we now have a revised share. So a cost is reduced for the generator. We're applying it already. Specified burden, even if you set up a plant in a remote area, you need a transmission grid. And the cost will have to be borne through wheeling. Wheeling is for every consumer in this country to pitch in, and the electricity rate will go up for everyone. Is that good enough? Well, you have to draw a line somewhere. You have to make a decision somewhere. So I don't think all the costs should be generalized cost or generalized burden. The ratio between specified burden and generalized burden has been revised, but perhaps the ratio is not still optimal yet. And Ms. Obayashi seems a little fed up, but may I continue a little more? Oh, Mr. Yamazaki, please go on. Go ahead. So wheeling cost under the Japanese system is set for each and every utility. For example, in the case of Niigata, the transmission grid, the cost thereof will be recouped by Tohoku utilities wheeling costs. So let's set up an electricity source in Niigata, and power will be sent from Niigata to Tokyo. And yet, because the wheeling cost is imposed upon Niigata citizens as well, they will have to bear the cost, although they're not the one who's using it. So how to recoup the cost, we really need further discussion and study. Thank you.
Peter-san or Matthias-san, in Denmark, what is the concept of paying for the transmission cost?
That we have a very different regulation and setup in Europe than what you are talking about here. We have transmission system operators, and we are responsible for developing the transmission system and operating it. And if you take Denmark, then all the cost for building and operating the transmission grid is paid by the electricity consumers on the transmission tariff. They also have a tariff for the local distribution, but it's only for the grid. And whether you put this burden on the generators or the consumers, at the end of the day, the bill will end with the consumers, because the generators, they have to sell the electricity at a higher price if they have to pay for transmission and wheeling. So the bill, the invoice, ends with the end consumer. So we have the tariff for the end consumer. We plan the transmission system for the whole of Denmark, and we make the necessary investments to enable the grid connection of the different generators in the sites where we have identified possible sites for offshore. So we have a long-term planning and a long-term investment plan to have the available grid. And I think long-term here is the key word, because it takes a long time to build new lines and develop the grid. You can set up PV or wind turbines within half a year for PV, or maybe 2 or 3 years for wind turbines. but it takes 10 years to build grid. So you have to be ahead, and you have to make this long-term planning on at least regional level, but preferable on national level to combine and connect the north and the south and the east and the west. And when we talk about these huge investments in generation and in transmission, you have to make a long-term calculation, because the long-term calculation shows that this is a good business case for the country. If you look at the grid lasts for 20, 30, 40, maybe 50 years, and wind turbine generation is maybe, I don't know, the lifetime, it's 25 years or something like that. And you are independent of fuel prices. So when I don't know about Japan, I'm very surprised about the very high levelized cost of energy here. And I don't see any reason why it should be more expensive here than in Europe and other places, because the technology is the same, the developers are the same, the vendors are the same. There must be something in the regulatory setup and the way you have organized your utilities that makes this very expensive. All international levelized cost of energy, you see that nuclear power is by far the most expensive, then liquefied natural gas, and then coal and others. And then in Denmark, onshore wind power is actually the cheapest type of generation you can have. To invest in onshore wind power and operate it is cheaper than using an existing coal-fired power plant. Even you take away the capex in a coal-fired power plant, the operational cost due to fuel and emission is higher than a new wind farm. So I don't see any reason why it shouldn't be here. So you have a lot of upfront investments in transmission grid and generation, and then you have actually free electricity for many, many years, independent of import of expensive fuels. And this is the way you have to make this calculation. And not say, oh, it's very expensive, it's very expensive. Yes, you have upfront investments, but on the long term, it's cheaper. And I think this is the perspective you have to take. We hear it all the time, it's so expensive, but it isn't. In the long-term perspective for the country, it's cheaper than going on with fossil fuels. Thank you.
ありがとうございます。マティアスさん、ちょっとじゃあ質問の種類を変えましてですね。
Thank you very much, Matthias-san. Changing a question a bit, you showed us a slide where Japanese companies are investing in Osted, Marubeni, Sumitomo. You mentioned Japanese companies. And in order to get a good investment climate, we know that Japanese companies are investing in your project. But your comments on that. And also a small country such as Taiwan, they have a 12 giga project. And so there must have been grid transmission related challenges, but the time framework and getting permits and licenses from the regulator and the government, if you could give a brief comment on these topics, please.
I mean, investment climate, as I said before, it's about the key game changer is that we have a clear and visible regulatory framework that is outperforming the subsidy by far, because that makes a long-term investment possible. And if we stick to the topic, I think in terms of how to distribute grid enhancement costs, I think the most important thing is to know before we have to take an investment decision how it will be distributed, and also distributed over, let's say, fairly. That means over a lifetime, time-wise, but it also means over what could happen during a lifetime on offshore wind. If we build a grid highway somewhere to the north or the south, and then there's not only one offshore project, there is probably many, many projects, and some of the projects we don't know yet about. So it needs to be a reasonable amount if you distribute it across the generators. And that is also a discussion we had in some of the markets. Otherwise, it will become very difficult to handle this burden. So clarity on how, and then of course also distribute in a way that it's not a few pioneer projects who have to handle the relatively high grid cost, but rather find a way to distribute it over 20, 30 years and many different projects and technologies. I think if you want me to share about Taiwan, in Taiwan, first of all, we have bottlenecks on the grid side that basically led to the fact that in an area where most of the offshore wind farms are concentrated, which is more in central Taiwan, there was a plan or is a plan to add 6.5 gigawatt of capacity, while there's development of roughly 10 or even a bit more. So we had to go through a you could say grid allocation round, which was basically related to you needed to qualify through different criteria, and that's capabilities, experience, financial strengths. So how capable the players really are in order to build these projects, because the worst thing that can happen is that someone grabs the grid and blocks the grid, who at the end of the day is not able to build the wind farm. Because then what happens is that the grid is gone and nothing will happen anyway, and everybody waits for the wind farms. And that we have seen, right? And that ultimately delays the market until you can really take away grid again. Many years go by, and all the penalties do not help. You need to do it right at the beginning with pre-qualification criteria related to the real experience and really enable people or empower people to build these projects who can really build them on time and on budget. And that was the first round, and then the second round was already the auction round. So the auction round for the second 2 gigawatt of grid which had been allocated was then purely price-based, and there people went into a strong competition. And what I said before is we grabbed 920 megawatt out of the 900 megawatt out of the first round, and basically another 900 out of the second round. So we got something on feed-in tariff, so we can gain experience and build wind farms in an early stage, and then we go in with a rather competitive price, which we can do based on all the synergies and experience which we will have by then. It's also a time thing, one project after the other. But some mechanism had to be introduced, and it was introduced fairly late, but still on time to keep the market on track.
ありがとうございました。それではですね、
Thank you very much. We would like to take questions from the floor, but 30 seconds each. It may be a bit repetitive, but for RE and offshore wind to be expanded in Japan, what is necessary? What does Japan need? Just in a word from your side, Wakuchi-san. Well, I publicized about Niigata Prefecture, but from a local government's point of view, people coming from the outside of the prefecture to generate power, that's appreciated, but we need to do this more locally. Well, there are lots of people who are somewhat wary of outside people coming for solar. And of course, some projects are successful, but it's not just about bringing money and investment. I hope you will have good dialogue with the local community, and that's going to be important.
Mr. Yamada?
I may be repeating what I said before, but without economies of scale, costs will not go down. So it's not to expand scale after costs come down. You have to make the decision to expand the scale and bring down the cost, and it has to be a private and public partnership-based endeavor.
Yamazaki-san? Yes. I'm sure there's a lot of criticism directed at me as a government official. But, we need to do things in parallel with each other. So increasing scale and bringing the cost down at the same time, simultaneously. So we have to rack our brains and collect expertise to achieve that. Thank you. Within ENRI, Renewable Energy Division is working very hard to expand RE. That's what you're doing, according to my awareness. So we would like to take questions from the floor. We will take 3-4 questions at once. I see a hand over there. Please state your name and affiliation. 1 question per person, please.
If I may, if it's only 1 question, we're very sorry, but if you could stand up and 1 question. I am My name is Fujio Mitsui. I'm an ordinary public citizen, and just one question that's difficult for me. But today, connection to the grid, in order to do that, you need to enhance and increase transmission lines. But in order to contend to the grid, you need to adjust the grid to accommodate integration of wind-generated power. So this adjustment mechanism, how to bring that down, and the balancing as well. So we were talking just about a reduction of cost, but balancing was not discussed. So what is your view there? And how are you going to bring down carbon element and the balancing? So in Germany, there is a reality that CO2 emissions are going up. So if you balance, can you really bring down CO2 emissions? And who is going to burden the cost of balancing? So Peter-san, if you could respond to that, please.
You need to balance variable renewable energy, and there's a higher balancing cost on variable renewable energy than on traditional fossil-fueled power plants, which are controllable. But if you look into the European example again, with efficient electricity markets and a strong transmission grid, the extra cost for balancing on renewable energy compared to traditional power plants is very limited. It's a very limited cost. And when I talk about levelized cost of wind energy, then this extra balancing cost is included in the levelized cost of energy. So even with this balancing included, onshore wind power is cheaper than coal-fired, the operational cost of coal-fired power plants. So it's not a big cost, but it requires a good transmission grid and efficient electricity markets with competitive players to bring down the cost.
ありがとうございます。それでは2問続く。
Thank you very much. We will take 2 questions at a time. I see a hand over there. Are you ready? If you're not asking a question, we'll just take 1 question. Please bring the microphone to the gentleman. Thank you very much for the very informative presentations. I have 2 questions. No, just 1 question per person, and state your name and affiliation, please. My name is Yoshimura. I'm a member of MPO related to renewable energy. Well, in today's discussion, one important aspect is lacking. RE is a local asset for the local community, and so the residents of the local community need to benefit from that. What was impressive about Denmark is off the shore of Denmark, there are wind farms, and they're invested in by the local people who live close by. So electricity generated from wind power is benefiting the local citizens. In the case of Japan, that is not the case. Local residents not necessarily benefiting from such projects. Well, Yamazaki-san said that we need to coordinate rights with fishermen. Well, fishermen, if they can benefit directly from offshore wind power, then no problem. That's the kind of mechanism we need to put in place. In the case of Aomori, the project is such that the local residents are not profiting from the project. And another point that I would like to direct to Mr. Yamazaki, you need to go a step further, collect and manage, you said. I think we should try to learn from Denmark. We need to have a non-profit transmission organization like TSO in this country as well. It's so embarrassing to waste surplus electricity in Kyushu, and we can't generate more in Hokkaido. So it's not just about unbundling. We need to go a step further. So we need a TSO under public control, a nonprofit organization. That is what is needed. So Peter-san and Yamazaki-san, if you could please answer. Yamazaki-san, if you would like to start, go ahead. Thank you. First, the local community, living with the local community, that is most crucial for RE. That is the essence of our renewable energy. We have to work together with the local community. Given the nature of electricity, well, electricity that's generated in the wind farm, can it be used directly in the local community? Well, technology aside, whatever the form, we have to collaborate with the local community so that we can generate employment and other benefits for the local community. Such a relationship is very important. Unfortunately, when it comes to solar projects that cannot collaborate with the local communities are happening, and that is a problem. So we as government would like to address that and solve that problem. With respect to the second part, unbundling, well, I think it's a step-by-step process. In Europe, that was the case. So unbundling was done, and unbundling of ownership took place. So rather than talking about separation of ownership first, we have to think about the history of Japan. We are divided into 9 districts. The case of Hokkaido, the problem in Kyushu, that's because of those 9 districts. So we cannot set up transmission lines right away, because we have this history of 6 years dividing the country into 9 districts. So for some bundling and recurring cost through OCTO, and beyond that, if there's further discussion, we should look at it. So first and foremost, we need to bring down the walls that separate the country into 9 districts.
Policies in renewables, I have made suggestions for a long time, but if we look at this METI and UNRES policies, I have seen the process of a negotiation. And Mr. Yamazaki, you have been involved in the reform of the electricity system, and now that you're heading renewables in Japan, you as the Agency for Energy and Natural Resources, it's a bold move. And so I think it is the recognition of the central government that renewables are indispensable, but it's so slow right now in Japan. And from EnergyNet, Pedro-san said 30 years, but we can't wait 30 years. Within a period of maybe 5 to 7 years, we want to be a country that can learn from overseas. So no more questions? If not, we'd like to move on to the reception, and maybe you can network and exchange ideas there during the reception.
Thank you very much, Ms. Obayashi. Please give a big round of applause to the panelists on the stage.